Hello everyone, good day. I'm Jasim Brian Singh from the group. So today we're going to talk all about solar panel efficiency tracker. So first, let me discuss what is solar panels. Solar panel is a kind of device that converts sunlight into electricity. So it has three main types. So we have the polycrystalline, we have the monocrystalline, and we have the lastly the thin film solar panel. So the most efficient type is the monocrystalline. So what is a solar panel tracker? So solar panel tracker is a device or system that moves solar panel to follow a sunspot across the sky, improving the panel's efficiency by maximizing the sun exposure. So there are two main types called the single axis trackers, which rotate on one axis, usually in the east to west. We have the dual axis trackers rotate on both axes, which includes east west and north south, offering an even greater lift. The goal for this is to maximize energy outputs, reducing costly maintenance. Like imagine you're an engineer working on a company and um, you did think that, or you would say to yourself that how much energy did we produce today? So in terms of that, here we did build a simple C++ program that accepts the least hourly energy outputs, and also it compares each one to a minimum expected value. It calculates the total energy produced, and it will be explained by my classmate Amy Pearl and Cyril.
So now let's dive into the C++ code. We now start with the standard C++ setup. Hashtag include iostream, which allows us, the users, to use the input and output functionalities like displaying the text on the screen. Using namespace std, which makes it for us, the user, easier to use these functionalities. Next, the end main with open and close parenthesis function is where our program begins its execution. And everything inside these braces will be run step by step. Next, we now declare two integer variables, num readings and min expected output. This will store the number of Harley readings the user wants to input and output, and the minimum energy output in watts that each panel is expected to produce per hour. This part here, see out, enter the number of readings, displays a message on the screen asking the user to enter how many Harley readings they will provide. Then cn num readings reads the integer value that the user types in and stores it in the num reading variables. Similarly, cout enter the minimum expected output in watts prompts the users to enter the minimum expected output in watts and stores that value in the minimum expected output variables.
For the initialization, the total energy produced is initialized to zero. This variable will be used to accumulate the total energy output from all the readings entered by the user. Each hour's output will be added to this value in the loop later on. And the suboptimal hours is also initialized to zero. This will be used to count how many hours at an energy output less than the minimum expected. For the loop to process each reading, this is a for loop that starts from I equals to 1 and runs until I equals num readings. It stimulates hourly intervals and output. A new variable is called output is declared inside the loop. This variable holds the energy output for the current hour. The program prompts the user to enter the outputs for that specific hour and the value is read using cn. Processing the output. This line adds the current hours output to the total. It equivalent to total energy produced equals total energy produced plus output. After all iteration, this variable will contain the total energy produced over all hours. And the condition checks if the output is less than the minimum expected output. After all iterations, this variable will contain the total energy produced over all hours. In this conditional checks if the output is less than the minimum expected output, the value the user entered earlier. And if it is, that means the output during that hour was suboptimal or below standard. So the suboptimal hours plus increments the counter by 1. In the final output, after the loop ends, after all the readings are processed, these two lines display the total energy produced across all hours with the unit watts and the number of hours with the output was below expectations.
So as you saw, our program takes in the number of hourly readings, the minimum expected output like 120 watts, and then each hourly output like 180, 150, 100 watts, then calculates the total energy produced 105 watts in our example, and pinpoints that hour that fell below the minimum 2 suboptimal hours. This simple yet effective tool empowers engineers to quickly identify performance tips in solar panel system, ensuring efficient and reliable renewable energy generation.